Hey guys, Mr. Longbreak here again. Today we're going to talk about the second stress or change that can be placed on a reaction at equilibrium. Last lesson we talked about concentration or amount. Now we're going to talk about increasing or decreasing the temperature. And the biggest thing to identify right away with the reaction when temperature is altered is whether it's exothermic or endothermic. And that is very important because if it's exothermic, that means more heat is released, meaning heat is going to be on the product side of the reaction. If it's endothermic, that means more heat is absorbed, meaning heat is going to be on the reactant side of the reaction. And when you increase or decrease temperature, before you figure out which way it's going to shift, you have to know that information. So with an exothermic reaction, if you increase the temperature, knowing that heat is a product, well, the reaction is going to shift in a way to reduce that stress. So it's going to shift to the left or away from that heat to reduce the stress. Now, if you decrease temperature of an exothermic process or reaction, the reaction is going to shift towards heat, and shifting towards heat here would be towards the products or to the right. Now, in an endothermic process, it's going to be the opposite because heat is on the other side of the reaction. If you increase temperature of an endothermic process, it's going to shift away from heat, which would be to the right in an endothermic process. And if you decrease temperature of a reaction, it's going to shift towards heat, and with an endothermic reaction, that would be to the left or towards the reactant side. Okay, so we have all that information. Now let's apply it to a few examples. Okay, so example number 1. So we have iron, 4 iron plus 3 oxygen yields or produces 2 iron 3 oxide and heat. And we have this double-sided arrow showing it is at equilibrium. Now, first it says, what type of reaction is this? And what it means is it endothermic or exothermic? Well, we can tell that by this heat term. Since heat is a product, meaning it's on the right side of the reaction, we know that more heat or energy must be released in this reaction, meaning that it is an exothermic reaction. And we have to identify that first to be able to answer the next two questions on what happens if you alter temperature. So this next question says, what happens if temperature is increased? Which way will this reaction shift? Well, if temperature is increased, it's going to shift away from the heat in order to bring that temperature back down. So think of your body, for example. If you increase your body temperature, say you're hot, you've increased your temperature, you're going to do things in order to decrease your temperature back down and get back to equilibrium, such as taking a cold shower or turning on the air conditioning or going in front of a fan. Reactions are the same way. If you increase the temperature of some reaction, it's going to shift away from that temperature that heat, in order to bring that temperature back down and get the reaction back to equilibrium. So this would be to the left. Now, on the other hand, what if you decrease temperature? Well, if you decrease temperature, it's going to shift towards the heat in order to heat back up that reaction and bring it back to equilibrium. Same thing, think about your body. If you're cold, you've decreased your temperature, you're going to do things to increase your body temperature back up. You might turn on the fireplace, you might turn up the heat, you might put on more layers, put on sweatshirts, hats, gloves, etc. to bring your temperature back up. Same thing with the reactions. If you decrease the temperature of a reaction, it's going to shift towards that heat in order to bring the temperature back up. And with this particular reaction, that would be to the right. Okay, now example number 2. It says, which way would the equilibrium shift in the following reaction if temperature were increased? Okay, so temperature's increased, and it's not as easy as just looking up above and seeing what happened, because that example was an exothermic process. Well, this is an endothermic process. And I highly suggest doing this. If it's endothermic, you need to add the heat term to the right side or the correct side. In endothermic processes, more heat is absorbed, meaning it is a reactant. And I'd actually write in heat, that way you can visually see where that heat is at. Okay, so if temperatures increase, just like your body, you're gonna find a way to decrease that temperature back down. Well, how does the reaction do that? By shifting away from the heat to reduce that stress. So shifting away from the heat in this example is shifting to the right or towards the products. And if you see up above, it was left in that example, and that's because it was an exothermic process instead of an endothermic process. Okay, this last example says, which way would equilibrium shift if the temperature were to be decreased? Well, first thing I'm going to look at, is it endo or exothermic? It's exothermic. So this time heat is a product because more heat is released. So I'm going to write in heat on the product side. And if temperatures decrease, the reaction is going to find a way to increase that temperature back up. And the way that the reaction is going to do that is by shifting right, shifting towards the heat. If a reaction's cold, it's going to shift towards the heat to make it warmer. If your body's cold, you're going to find ways to make it warmer. Same concept. So in this reaction, if temperature were decreased, it would shift to the right or towards the products. Okay, so hopefully these examples help you out with the second stress or change that can be placed on a reaction at equilibrium, which is temperature. As always, if you have any questions, please let me know. And I miss you guys. Look forward to talking to you soon.